So chapter 13 and chapter 14, they're going to talk about regression. Chapter 13 is going to talk about two variables. We're comparing them together and drawing a graph and seeing if there's a line, just like in algebra, how we looked at it. We had an actual formula we come up with so I could predict what it would be at a certain point. And then we also have chapter 14, which is going to talk about multiple regression, which means I have several of the independent variables that I'm applying to the dependent variables. So I want to see how your grades are impacted by the hours you sleep, your age, your gender, all these other things. Excuse me. Multiple regression will analyze all of those together and come up with this pretty graph to show if there's an overall trend and then individual trends and all that. And then, but chapter 13 is just going to talk about two variables. I want to see if there's a correlation between the example I'm going to use, the car price and or the car's age and the price that it sells for. I want to see if there's a correlation between those two. Now, correlation doesn't necessarily mean causation. You have to also analyze outside of this, just from your viewpoint, can these two impact each other? If you look at car prices and the age, well, yeah, an older car, most likely, unless it's an antique, isn't going to generate the same amount of revenue or profit from selling it as a newer car. So we can look at that and say there is a logical connection. But I gave an example of a snow cone stand built on the Galveston Island or at the beach. If I built a snow cone stand on the beach and then the next week shark attacks go up, the two can't logically be connected, although they can be graphed and look correlated. So just because two things are correlated doesn't mean they cause each other. So that might be something I ask you about on the test. We're going to talk about dependent and independent variables, calculate and interpret coefficient of correlation, determination. We talked about some of this before the test. We introduced this. So regression analysis is going to see, again, if there's a relationship between two variables. And that dependent variable is going to be the one that we have the outcome for, so your grade. The independent variables are going to be the ones that I can't manipulate, your age, your gender, your classification. Is this the second time you've taken stats? Whatever it may be. So correlation analysis is just going to give us a number that's going to tell us how related two variables are. If there's a negative, positive, or no correlation at all. Scatter diagram is going to be the way that we represent that. So if on the homework it tells you to do a scatter diagram, please go to Excel and do it, because it's going to take you, it may not take you that long to do on the homework, but it can be a little tedious, so you don't want to have to worry with doing that. Dependent variable is a variable being predicted, again, your grade, as in the example I gave you, or the selling price of the car. I can't change the age of a car, but I can change or see how the price is impacted by that. So think about which one can be impacted. If I put a newer car in there, then the price is impacted. And here's the example. And we're going to use this for doing Excel. We're going to use the one on, well, I think I'll get to it in just a second. The example of the car prices. So if you want to go ahead and flip to that one while we're looking at, this is copier sold and the sales calls made. The one we're going to go through, for example, is number 6 on page 740 or 472. So this one, we're going to see if there's a correlation in the number of calls that a salesperson makes and then the number of copiers that are then sold. The calls are what I can manipulate. The copier sold, that's going to be dependent on the number of calls I make. So the independent variable is going to be the number of sales calls. The independent variable is on the x-axis. The dependent variable is going to be on the y-axis. The y is always the one that we're predicting, and we only usually have one y that we're predicting. We can have several x's. Again, if we have the multiple regression, we're looking at several things, like the number of sales calls or the weather outside, whatever it is. So the correlation, again, is going to tell me the strength of a correlation. I can look at a graph and say, oh, it looks like they're correlated. One goes up, the other one goes up, or one goes down, the other one goes up, whatever it is. But I want to have a number. This is a perfect negative correlation, so just because they're opposite, they can still be correlated. So this is the age of the car or selling price. So one is going up, the other is going down. And positive correlation, perfect positive, means that it's a positive one. And here's how we would judge this. So if again, I gave the example of, moderate to weak. There's a gray area there, but I just want to know that you understand what the difference in a strong one or a weak one or no correlation at all. And this is what they look like when I do a scatter diagram. You can see that there's a trend on this one. On this one, may not be as much, or it's very weak. And this one's just everything is scattered. And this R squared is going to tell me, it doesn't give me any information on the relationship, like if it's negative or positive. It's always going to be a positive number. It's just telling me just the strength of that correlation. So on this one, it's not telling me the direction. So once I come up with the R, all I do is just square it. So if I'm going to test, if I give you the R squared, ask what's the R, you'll be able to do the opposite. But again, it can be negative. So the R squared is always going to be a positive. And I'm going to show you how to do this on Excel so you're not having to actually work out this formula right here. If you want to work out this formula, there are examples, and go ahead, feel free to do so. But Excel, you have like 3 clicks and you have the answer. So I'd rather do it that way. You can see here the number of sales calls and the sales that are made. And I come up with a correlation right here of this positive 7.59. So there's a positive correlation between these two variables. I come up with the R squared, which comes up with 0.576, and it seems like it's shaking, which means 56.7% of the variation of the number of copiers sold is explained by the number of sales calls. So it tells me the strength of the actual relationship. So I can still have a positive correlation, but it may not be very strong as far as that one variable that I analyzed. It may be that it's the hours that you study, not the hours that you sleep, that give you the better test grade. So let me skip here. I'm also going to come up with the same thing like we did in chapters 11 and 12. I'm going to do a hypothesis test on if there's a significance in this correlation. And I'll show you how to do that again in Excel. I'll come up with this value, t value, z value, whatever it happens to be, and it's the same thing. Again, Excel is going to show you, yes, it reject or no, don't reject. But that's what I'm testing here. Kind of a longer formula to get to this R. But if you get the R off Excel, you can just plug this in here and see if there is a correlation here, or a strong correlation. And because it gets to this area, see, this T is much shorter than doing the other one. But I come up with the 3.297. My cutoff was 2.306. Again, looking in the back of the book the same way I've always done it. And I say, yeah, we can reject the null. The null means nothing has changed, that there's no relationship. The alternate hypothesis would be, yes, there is a correlation. So yeah, you can say, yeah, I've proven that there is a correlation. Now we deal with the linear regression equation, which gives us some information on predicting future outcomes. We're going to use this in 309, economic forecasting. I've said it before, just in case you weren't in here. Keep this book for economic forecasting, because it's easier if you've already learned from this book. You can flip back and review some stuff. They're going to refer back to this book, especially chapters 13 and 14, a lot. So keep this until you're done with that class. So just my word of advice. And take 309 as soon as possible. I come up with my linear regression equation, which is just the slope of or the line equation that we deal with in algebra. And I have a y-intercept, I have a slope. And here they are, how to calculate these. But I'm going to show you how, again, you can do this in Excel. Remember, slope is going to be rise over run. I go up 1 or down 1, and then over right or left, and I can plot everything. But basically what this does, in algebra, you're actually graphing this, and you're worried about how it graphs out. But this one, we're more worried about making a prediction. So I would be able to enter in something for x, and I already know what my b is, and my a, my slope, and my y-intercept. I know what those are. And let's say that this is an example of the hours that you slept, or hours that you studied, and then your test grade. This y hat would be your actual test grade. And then I'd be able to say, okay, if somebody slept 7 hours or studied 2 hours before the test, what should their grade be? I'd be able to make a prediction. And then I can see how far off the actual numbers are compared to my prediction. This is what a linear equation would look like. Again, you can go through calculating all of this, but it's a very simple step on Excel. I have all my dots plotted, and then the computer is going to graph which one is best fit for that data. So here's an example. I have all this information, If I made 20 sales calls, what could I estimate the number of copiers sold? So first I want to find the slope. Again, I can do this in Excel, but very quickly I can go through here because you have to find your standard deviation. Then I have the y-intercept. So come up with all this information. Again, we'll go through how to do this in Excel. But if I plug this in, you can't necessarily do this in Excel. If I plug this in and say if I made 20 sales calls, then I'd be able to predict this. So on the test, I might give you this information right here and say, okay, according to the linear regression equation, if I made 20 sales calls, what are the number of copiers I should make? If your answer is 40, because all you do is look on here and go, oh, there's 20. Oh, there's 20 and 20. And, okay, I'm just going to average those together. That would be an incorrect answer. So make sure you go through the steps of coming up with your linear equation. I'd be able to quickly calculate this. These are estimated, which means that I plug in each one of these into that linear equation, and instead of having the actual that they made, the actual sales, then this is what the linear regression equation says that I should get. So if I made 3 columns for these numbers, the sales calls, the estimated, and then the actual, I can see how far off that I am. That we said, I think this guy had gotten 20 sales, or 40 sales. We can see it's, okay, the estimated he should have gotten about 42. And here you can see where everything is above or below or exactly on the line. So, let's look at Excel really quick. I think I have it open, yes. Okay, so if we look at number 6, I have the age of a car and the selling price. And I want to see if there's a correlation between these two. So the first thing, remember, just as a review, if I can get to it, make sure that you go to options and that you go to add-ins and add in this analysis tool pack. So I want to come up with my regression, my correlation. So the first thing I do, you can go several places, but you can just click here and most recently use statistical, and I find correlation. Correlation, if I can go the right way. And then I have the first one and the second one. And I accidentally clicked over here, so we'll take this over here. There we go. So make sure before, sometimes you have to just play with it because you don't know if you're supposed to click on something before or after, and you don't figure it out to the end. So first thing you should have done on this, click somewhere, and that's where it's going to produce the answer. So I would just go over here and type in correlation here so I know that's what I'm talking about. So there is a negative correlation between, and it's a moderate one, between the age of a car and then the selling price, which means as the age of the car goes up, the price of the car goes down. Now I want to graph this, and I think I highlight it first. Let me make sure. I go to other charts and go to XY scatter. Now some of them are a little different. Some of them there's a little chart wizard, and it'll take you through the same steps. So know that you may have to do some Googling if your Excel is a different version. But again, I want it to be the scatter diagram, and here I have this information. If I want to change, like I don't want the title price, of course I can click on it, but I can also go here to the layout and change the axis titles, the data labels, whatever I need, if I want to change the legend, because I have several things on here, whatever it may be. I also want to see, this helps me if, again, I'm doing a scatter diagram, but then it doesn't show me the line. So if I ask for you to present to me the line, then you would be able to go to trend line, and then a linear trend line, and it would show you this. To figure out, to have the actual display of the linear equation, go to more options, and here display the equation on the chart, and you can also display the R squared on the chart. It'll be right on the chart, so move it over. And then I, again, have my information here. I would be able to look at this and plug in X and just do this by hand and have an answer. So there you have like all of chapter 13 test questions wrapped up here. You're able to answer so many questions. Questions on how you do this so far?
How'd you get the R squared again?
The R squared, for this, how I did it here, I just went to, where am I, layout, trend line, and then go to more trend options. This is if I already have the chart, and I just click on display the R squared in the chart. But I can also go to, I think it's here, statistical, thought I had it. If you just do the correlation, then you just square it. There's another place, I'll have to find it. This is a different version than mine on my computer. The next thing is to go through, again, you have the prediction. You're able to tell me your R squared, or your R and your R squared. You see that this is just squared, so I'm able to make a prediction. Going back to the PowerPoint, let me see if there's anything else to go over. This kind of covers chapter 13. I'm not really worried about standard error at this point. Okay, so multiple regression. I think that's the next one. Or just regression, not multiple. Yeah, regression. So multiple regression is going to be, here I have the age of the car, and then I have the price. But I might also have the color of the car or the type of car. So I have several different variables to analyze. Let me pull this one up. 14. So what we'll be able to do is set up an ANOVA table and be able to see, is there an overall significance for these variables, and then I can look at them individually and see if to what degree or which one's more or whatever. So for multiple regression, this is my equation. And now you can see why you don't want to do this by hand, because you want to do this in Excel. What this is saying is that there's several different variables. And before we're talking about something, again, linear. We're talking about two-dimensional, two variables compared to each other. Now we're talking about different dimensions of variables. So for some of my research, I study gender, race, religion, whatever it may be, several different variables, and then on this one outcome. And I want to see, is there a difference? I want some program to go through and analyze it all at once, so that way I'm not having to do 4 or 5 different problems analyzing each one of these variables. So that's what multiple regression does. And this is an example. I have a real estate agency who wants to analyze the selling price, I think it's the selling price, heating cost of the homes. And they're analyzing several different variables. We have the mean outside temperature, the attic insulation in inches, and then the age of the furnace. I want to see, is there an overall significance to these variables? Is there an overall connection or correlation? So this is my y-hat. This is what I'll be predicting. That if I know what the temperature is outside, if I know how many inches of insulation I have, and if I know the age of the furnace, if I plugged all these in, I would be able to come up with what the estimated heating cost would be. As a real estate agent, that might help in telling your clients what to predict. So this is the X1, X2, and X3. 3 different variables. What I would do, and this is showing in Excel and Minitab. If Minitab, we don't have that here, but the Excel would definitely be able to help you. You can barely see it though. You're able to look here and see what the coefficients are. You come up with this degrees of freedom, the ANOVA table, just like we did in chapter 12, but it's not set up a little bit different. But then right here you can see there's an F, and I want to see if there's a significance in these. I have my slope and my y-intercept for each one of these variables, and I'm able to look at these and say, oh, as one goes down, one goes up. So here's an example. I'm plugging this in. If I go back here, let me go back. If I give you this information on the test, an example of the question I'd ask, and this is again the online test, I would say, okay, given that the temperature is blank, blank, and blank, or whatever, the attic insulation and age of the furnace, predict the heating cost. So I've come up with, if I go into Excel, I've come up with what my y-intercept is, and it says intercept here, I know it's hard to see, and then these are going to be my slopes for each one of these. And I'm able to write out an equation and estimate this. So on the test, I will ask you something like this. Here's my linear equation, I'll ask you, what's the linear equation? Pick which one it is. You'd be able to tell me what it is. I have the minus here, remember, because that was a negative. And so now I'm able to estimate something. Here they want to know if it is, what's the first one? I don't remember what the first one was. The mean temperature outside, and then the attic insulation, and then the age. So we're saying this is going to be 30 degrees, we have 5 inches of insulation, and the furnace is 10 years old, that the estimated heating cost should be $276.56. That you would be able to tell me that, and that's what we'll be doing for multiple regression. Again, with multiple regression, you're going to be taking this into 309, so make sure that you are keeping this information fresh. I know this is what you want to do all summer. Let's see. So your hypothesis would be that, remember, there's no change or that they're not equal. They're either equal or they're not equal. We're not really worried about which one impacts more. That's going to be something for you to do a further analysis as a researcher. And I think that takes care of that. So what we're going to do is go through an example of some problems on Excel. What I want you to do is look at, let me pull up a question for you. Well, let me do regression real quick before we do, delete this. If I want to see, again, have the ANOVA table here, then I would just go to data, where is it? Statistical. No, wrong one. Data analysis, and I want to go to regression, which is right here. I click on that. And I want to have my Y input. It's important that you know which one is your Y and which one is your X. And my X input. Make sure that if you highlight your labels in the top row that you click here. Your confidence level, that may change for a problem. So make sure that you change that. Again, it's mostly going to be 95 or 99%. And then I'm going to put it on this table over here. If you want anything else to be analyzed, which is more for chapter 14, which we'll get to, here we go. I'm able to have my whole ANOVA table. I might ask you what the p-value is. I might ask you what the F is. If I calculate this, then what F do I come up with for ANOVA? I have it here. I can go through 45 minutes to an hour working out one problem, or I can take 30 seconds and do it this way. So I've recorded how to do this. If you forget how to do this, then it's on here. Also, if you Google it, you can find everything. Here's more information. I have my R squared, my R, and this is multiple R, which means it's not going to show the negative. I have the number of observations. I have all my degrees of freedom. I have every bit of information that I would need to fill in these tables for the final. Multiple regression is going to be the same way, except again, I'm going to have other variables here. I go do the exact same thing. So what I want to do is look at